Page 110. What are two types of energy? Moving objects such as vehicles shown in figure 2, talking about this right here, have one type of energy. A rock perched on the edge of a cliff or a stretched rubber band has another type of energy. So the two basic types of energy are kinetic energy, and potential energy. Kinetic means it moves. It's moving energy. Potential energy means it is not moving, but it could. So whether energy is kinetic or potential depends on the motion, the position, and the shape of the object. So let's talk about kinetic energy first. A moving object can do work when it strikes another object and moves it. For example, a swinging hammer does work on a nail as it drives the nail into a piece of wood. The hammer has energy because it can do work. The energy an object has due to its motion is called kinetic energy. So it's motion, kinetic energy. Factors affecting kinetic energy. The kinetic energy of an object depends on both its speed and its mass. Suppose you are hit with a tennis ball that has been lightly tossed at you. It probably would not hurt much. What if you were hit with the same tennis ball traveling at a much greater speed? Then it would hurt. The faster an object moves, the more kinetic energy it has. Kinetic energy also increases as mass increases. So suppose a tennis ball rolls across the ground and hits you in the foot. Compare this from getting hit in the foot with a bowling ball moving at the same speed as the tennis ball. The bowling ball is much more noticeable because it has more kinetic energy than a tennis ball. The bowling ball has more kinetic energy because it has a greater mass. So looking at this picture, we'll answer kinetic energy of an object depends on its speed and its mass. So here we go. We're talking about kinetic energy, and it's going to depend on the speed of the object and also the mass. So list the vehicles in order of increasing kinetic energy. Go ahead and look at these. We have a car going 30 meters per second. We have a motorcycle going 20 meters per second. And we have another car going 20 meters per second. What you know about kinetic energy, list the vehicles in order of increasing kinetic energy. Then you want to describe another example of two objects that have different kinetic energy. Explain why their kinetic energies are different. So, looking at these, order of increasing kinetic energy. So the least would probably be the motorcycle going 20, then the car that goes 20, and at the most it would be, or the one on the bottom would be increasing, the most would be the red car going 30 meters per second. Okay, and explain your two examples. Explain why their kinetic energies are different. So you come up with something that is similar to this example in the book. All right, we'll keep going. Knowing about calculating kinetic energy now, you can use the following equation to solve for the kinetic energy of an object. So this is a little more complicated. Kinetic energy is you take 1/2 times the mass times the speed squared. For example, suppose a boy is pulling a 10-kilogram wagon at a speed of 1 meter per second. So you would take 1/2, the kinetic energy is 1/2 of times the 10, that's the mass, the blue is the mass, 10 kilograms. That's measured by weighing it. Your mass you usually weigh, and the speed is 1 meter per second, and we square it. Well, 1 squared is always 1, so 1/2 of 10 is 5. Do you see how they're doing that math? So 1/2 of 10 is 5, or 10 divided by 2 is 5. The label will be kilograms times meters squared and seconds squared. And that equals a joule, 5 joules. So just remember that 1 kilogram per meter per second squared is a joule. So we're going to highlight that because that is very important notation of what a joule is. So, do changes in speed and mass have the same effect on the kinetic energy of the wagon? No. Changing the speed of the wagon will have a greater effect on its kinetic energy than changing its mass by the same factor. This is because the speed is squared in the kinetic energy equation. So, for example, if you double the mass of the wagon, it will double its kinetic energy, but doubling the speed of the wagon will quadruple or square it, its kinetic energy. You would see that better if you would say the wagon is going 2 meters per second. Well, 2 squared is 4, and that's how they're getting the quadruple. So speed would be more of a factor in changing your kinetic energy than mass would. A girl and a dog are running. The dog has a mass of 20 kilograms. The girl has a mass of 60 kilograms. So suppose both the dog and the girl run at a speed of 2 meters per second. Calculate both of their kinetic energies. So use this equation up here and solve for the 2 equations of the kinetic energy of the dog, because you know the mass for both and you know the speed for both. Then, number 2, calculate. Suppose the dog speeds up and is now running at 4 meters per second. Calculate the dog's new kinetic energy. Are your answers in question 1 and 2 reasonable? And then explain why. Relate cause and effect. What has a greater effect on an object's kinetic energy? Doubling its mass or doubling its speed? We talked about that, but kind of explain it in your own words right here. Good job.